Hey, Assalamu alaikum. Today we'll be going over the topic of abstract data type, and it is 10.4 of our syllabus of P2. So, first we need to know what an abstract data type is. So, an abstract data type is a collection of data and a set of operations on that data. So, now we need to know there are three abstract data types in our syllabus. One is the stack, the queue, and the linked list. So, first of all, we'll be beginning with the stack. So let's go over what a stack is. So first of all, what we need to know is what a stack is. So it's a list containing several items operating on the last in first out principle or the first in last out principle. Items can be added and is known as pushing an item out of the stack, and when an item is removed, it is known as popping it. So uses a stack. So a stack is used because of memory management, expression evaluation, and backtracking in recursion. Okay, so another thing that is important about this is that a stack is usually numbered from the index is numbered from the last element to the topmost element, which is the last element. In this case, the bottom pointer is always pointing to the first index, and the top pointer is pointing to the index where the last value is entered. So now we'll begin on what kind of operations do you need to know in order to attempt a stack based question for CIE P2 syllabus. So here we're gonna import a stack inside, and now we're gonna read what's written, what's given to us by an examiner. So it states that we need to show the stack and the values of the top and base pointer when an item has been popped off the stack and 67 followed by 27 have been pushed onto the stack. So it's basically telling us one item is popped and two items are pushed into the stack. So first of all, if we begin by popping an item off, so basically the item is going to be popped off, and the top pointer is going to point to index number 4 now. But as soon as we add another item, which is 67, right, so the top pointer is going to move up. So the top pointer is going to move to position 5 back again, and when another item is added, which is 27, the top pointer is going to move again. So that's how a stack basically works, and this is all you need to know on how a stack works. Okay, so the next abstract data type that we'll be talking about is the queue. Okay, so as you all may have known what a queue basically is, so it's like how a real life queue is implemented. So it is a list containing of several items which work on the first in first out principle, and the items can be added to the queue and is known as an N queue, and an item can be removed, which is known as a D queue. So the basic uses of a queue is managing files that are sent to a printer, or buffers used with keyboards when you press a key and an alphabet appears on your screen. Apart from that, it's also helped in scheduling. As you know, each schedule is designed with first dates in mind and how to progress. A queue basically looks like this. It contains a front pointer and it contains an end pointer. Okay, apart from that, we need to also understand how the queuing operations work. So, first of all, we need to know that the value of the front pointer changes after a DQ, and the value of the rear pointer changes after an NQ. Okay, so now we'll be looking at a question and we'll see how we can attend to it. Okay, so the question states that we have a circular queue. So what we need to be aware about is that the rear pointer does not go to the end and get stuck, so it resets back to original lower bound of the index. Okay, so what we need to do here is show that the circular queue and the value of the length of the queue, front pointer and rear pointer, when three items have been removed from the queue and 25 followed by 75 are added to the queue. So here we'll take help from what we just learned right now. So that we learned that the value of the front pointer changes after a DQ and the value of a rear pointer changes after an NQ. So first of all, we are DQing three items, right? So three items are being removed, right? So first of all, we'll remove 61, and the front pointer will now point to 38, right? So the front pointer will now point to 38, and then again, that is one item removed. Now we'll remove the second item, right? So when we're removing the second item, the front pointer will now point to 31 again. It's the upper bound or lower bound one, index positions 31, right? And now we have to remove another item from here, so we're going to be removing this 31, and then finally our front pointer will be pointing to 55, right? So here is the final position of our front pointer. And now the next piece is of task, or that 25 is added and then 75 is added. So first of all, we're going to add 25. Therefore our rear pointer is gonna move, and the rear pointer is now going to be pointing at 25. So here is our rear pointer, and then 75 is added, so our rear pointer is gonna move again. So our rear pointer is going to move, and then it's going to point to 75. So this is how our queues work, and this is the basic functionality of how a queue works. And now that we are done with our assignments, so now we have to count the length of the queue. So if we can see, there's one element at position number 2, another element at position 3, another element at position 4, and the last element at position 5. So in total there are 4 elements. Therefore length of queue is 4. So this is the basic functionality of how queue and a stack works. Thank you.